A system cannot reliably audit its own output. That's a real sentence from a real video script in this repo, stated as fact, structural, settled, so I went looking for the number behind it. The tally, the trial, count, anything. There isn't one, not in that sentence, not anywhere in the script. All right then, let's go find out. Hi, I'm Tanmay Kulkarni. Here's the question: when an AI gets something wrong and you ask it to check its own work, does it catch the mistake, or does it just agree with itself? There's a claim going around that it structurally can't, and I picked this topic expecting to confirm it. Genuinely, I thought I'd watch the model wave its own mistake straight through and come back with a tidy little demonstration. That is not what happened. 33 wrong answers, 3 model setups. And a result I did not see coming. But the useful part isn't what I found. It's how I checked, because the way that claim was originally tested couldn't have settled it either way. And that works on any claim you care about. Anytime somebody says a system fails because of something, here are 4 questions that decide whether they've got a finding or just a good story. First, what's the claimed cause? Second, what else would produce exactly the same thing you saw? Third, is there a version of the test where only that cause changes and nothing else? And fourth, the one I learned the hard way, will that test actually collect any data? The first 2 are cheap, the third is the one people skip. And the fourth is the one I skipped. Start with the claim I found. Its cause is self-reference, the model checking its own work. Same weights, same activations, same direction of error. Fine, so what's the rival? That the puzzle is simply hard. A model that gets the arithmetic wrong and then stays wrong isn't protecting its ego. It just can't do the arithmetic. Those 2 stories predict exactly the same thing. And the experiment as written has 2 arms. Ask the model to check itself, then check it in Python. Both arms change everything at once, so it can't tell them apart. That's not a wrong conclusion. It's no conclusion. And in fairness, this is a subtle mistake. It is absolutely everywhere. Here's what was missing, and it's small. Take the wrong answer. Show it to the model twice. Once inside its own conversation where it looks like its own work. Once in a completely fresh conversation where it's presented as somebody else's submission. Same expression, same question. The only thing that changed is who it appears to belong to. If self-reference is really the cause, that gap should be enormous. If it isn't, the gap is nothing. Either way, now we can find out. So I built it, ran it, and it didn't work. Not the code. The code was fine. The models were just good. Sonnet 5 solved 9 out of 10, then 10 out of 10, and you cannot measure how often something catches its own mistakes if it doesn't make any. My best arm, the one I actually cared about, had 0 trials in it. 0. I'd built a control that never fired. That's question 4. It's on the list because I got it wrong. The fix is what the published work actually does, and I should have read it more carefully the first time. Don't wait for a mistake. Make one. Take the model's correct answer. Corrupt exactly 1 operator. Now it's wrong, it still uses the right 4 numbers, and I control how wrong, subtle, moderate, obvious. Every trial has something to catch. And crucially, the version I show it as its own and the version I show it as a stranger's are now character for character identical. 33 wrong expressions, 99 verdicts, 3 configurations, 0, not low, 0, it caught every single one. And the gap, the entire reason the experiment exists, was 0 as well. It was exactly as good at catching its own mistake as catching a stranger's. Provenance made no difference at all. I reran the grader twice because I didn't believe it. But hold on, because this is exactly where a video like this overclaims. 0 out of 33 does not mean 0. Run the actual statistics, and what I can honestly say is that the true rate is somewhere below about 9%, not 0, below 9, and it's one task, arithmetic, 4 numbers, and answer a Python function settles in a millisecond. That is the easiest possible thing in the world to check. Nothing here tells you what happens with code review, or a factual claim, or a judgment call. Which brings me to the part I actually care about. That original script said 2 things, and they sound like one thing. It said, don't let the model be judge and defendant, put a real check in there. And it said, because a model can't audit itself. The second one is wrong. I just watched it audit itself 33 times out of 33. But the first one, keep it. And here's the reason to keep it. The only reason I know that rate is low is that there was a Python evaluator sitting outside the model, grading every single answer. Take that away and I don't have a finding. I have a model telling me it checked. The external check isn't the safety net, it's the instrument. One more thing, because I nearly didn't publish this. I set out to demonstrate an effect and I found nothing, and the reflex there is to quietly bin it and go find a topic that works. That reflex is exactly why claims like the one I started with stay in circulation. Nobody publishes the run where it didn't happen. A null isn't a failed experiment, it's an experiment that answered. So your turn, take a claim you believe, something with a because in it. It fails because X. Write the cause down in 1 sentence. Then write 1 rival explanation that would look completely identical from the outside. Then describe the test where only the cause changes. If you can't describe it, you don't have a finding yet, you have an observation. And then ask the last one, would that test actually collect any data? or are you waiting on a failure that almost never happens? Find one claim you believe that has no arm behind it, and that's the whole exercise. If everything you own passes on the first read, you graded yourself gently. The experiment, the data, and every transcript are linked below. Run it yourself, it costs about $1. Thanks for watching. I'm Tanmay Kulkarni.